Thank you for the introduction. I'm going to share the secret recipe of AI algorithm, how to leverage deep learning algorithms for the detection of acute intracranial hemorrhage, brain bleeding. This is an important clinical problem. We are trying to tackle stroke patient management problem. Stroke is a major cause of death and disability worldwide. 15 million people worldwide suffer a stroke each year, and 5.8 million people die from it. There are two types of strokes. Ischemic strokes, 80% of stroke is caused by narrowing or blocking of the arteries to the brain. Another one we are targeting right now is a hemorrhagic stroke. It's a bleeding. 20% of stroke caused by leaking or rupturing of a blood vessel in the brain. In the United States alone, it kills about 140,000 Americans each year, one of every 20 deaths. It happens every 40 seconds. Each year, about 795,000 people suffer with this stroke. Because of this, stroke costs the nation $34 billion annually. This is a time-sensitive problem. Within minutes, the brain cells begin to die. Because of this time-sensitive manner, when the face is drooping or you cannot raise your arms, your pronunciation is not right, not normal, then you should call 911. But what if there's no response? My question is, how far can you drive to check in the best hospitals? Or how do you find the best doctor to read your CT scans? How quickly do you hope your CT scans to get screened? What if a group of best doctors to train a deep learning algorithm to detect stroke instantly? Our paper published in Nature Biomedical Engineering last year. There are so many AI algorithms out there. Why this paper is unique and different? Because it's tried to explain the explainable deep learning algorithm. Why explain is very important. You have a best doctor. It predicts your disease, or you diagnose any disease. But what if he or she cannot explain why you diagnose this disease? Likewise, AI is the same thing. Best performance AI algorithm, it cannot explain why it predicts this result. That's a big problem. Also, people try to use a big data set, huge data set. It's very hard to collect. But we could achieve a high performance algorithm with a small data set. It's unusual, but Google Cloud people published their commentary paper in Nature BME with our paper. Also, media covered our paper saying Massachusetts General's AI can spot brain hemorrhage as accurately as humans. Why this is the big issue? In the deep learning AI field, there's a native, natural questions. Why AI is so good, but we don't know what it happens and inside of this black box. Our approach is explainable AI. I'm going to show you how we made this happen. And AI algorithm is a superhuman result provide, but everybody say, oh, we developed this AI algorithm, but we need more data to improve the performance. But that's not going to happen easily. We use the small but high quality data to make this happen. And also, out there are open source algorithms. People share their algorithms codes, but there's no unique algorithm for specific target functions. But we developed the human mimicking algorithm in our AI algorithm. This is explainable AI. As you could see, the top layers, it's the same as other AI algorithm, but bottom is a unique one. We developed the visual explains for the diagnosis. We make this result is visible so that you don't need to read anything. You can instantly recognize the result and predictions and the justifications. We developed two functions. One is attention map, and second one is a prediction basis. I'm going to show you what's attention map. The top graph is x-axis is a slice number, y-axis is a prediction of bleeding. As you could see, there's a red line and the blue lines. It could detect the multiple different types of hemorrhages. In this case, we detected 2 types of hemorrhages. This is attention map. Many other algorithms out there, we can identify where is the bleeding. We identify location of bleeding. But this is a prediction basis. It justifies why AI is thinking this is a right bleeding, why this is the right types of bleeding. These are the different 5 different types of hemorrhages, different locations, different lesions. I didn't generate this prediction basis. AI generates automatically. It tried to explain why AI is thinking this is a specific bleeding types. Also, we try to mimic human radiologist practice. Radiologists keep changing their contrast windows and scroll up and down the g-axis of 3D volume data set. We combine this human mimicking functions in the algorithm. One is a multi-window mixing, and the other one is a multi-slice mixing. In this way, we could achieve a high-performance algorithm. We try to implement in our PACS system. This is a prototype. We already put our function in the PACS system. The whole stroke management workflow consists of 5 major functions. We developed the first bleeding detection AI algorithm. This is AI-enabled stroke workflow. What if we could implement this in small hospitals, just a stroke-ready hospital, and or acute stroke hospital medium size, or we connect all of these hospitals with a comprehensive stroke center, we could save a lot of lives and save a lot of money. What's the current status of this project? Real-world test result, unfortunately, I cannot share here because our abstract was invited to American Society of Neuroradiology. They are considering our paper for DIC award, so we just submitted last week. And also our softwares are packaged in the Docker form so that it can be deployed in any types of Google Cloud. It can be used, deployed in the China, India, Korea, anywhere. Why MGH stroke AI algorithm? MGH doctors developed and tested and will continue to improve it. And also, how do you trust this AI if you don't understand what's going on inside of this AI algorithm? There are millions of parameters in there. Also, people try to attack those algorithms and CT scanners. Our approach is rigorously evaluated in academia and also keep improving it. And this is protected by our IPs. We are looking for funding opportunities and partners happy to share this algorithm if you want to deploy in your clinics or hospitals. And we are looking for advisors can help us to make a big impact in this stroke patient management field. please come and talk to me. Thank you for your attention.